Hello, and welcome to Life in the Fasting Lane podcast. Each week, we are here to educate you, challenge you, tell you about keto, talk to you about fasting, mostly intermittent fasting. You can check us out at fastinglane.com and on Twitter and Instagram at fastinglane. Our guest this week is Dr. Benjamin Bikman. Benjamin T. Bikman, PhD, is the Associate Professor of Physiology and Developmental Biology at Brigham Young University in Utah. And he said I could call him Ben. So hi, Ben. How's it going?
Hey, Eve. It's going very well. Thank you. What an introduction.
Did you like that? Well, all the best people I meet typically are told to me by Dr. Jason Fung and Megan Ramos. All the cool people that know different things, they basically, they tell me who to know. And they said that you were a super smart guy. And I, had been living under a rock and hadn't heard of you before, started watching your stuff. I can see all the things that make you really interesting to people. But I think you're super, super smart. So I'm excited to have you on the show and see if you can teach us some of this stuff in an everyday kind of language, because that's what I need, man.
Yeah, well, hey, but thank you. That's very kind. Let's not confuse smart with curious. I'm just curious. And the answers I've found happen to be to questions that it appears a lot of people are asking. So and a PhD, all that means is someone was really patient. That's it. Mm-hmm. There's no magic to it.
And a hard worker. So
a little hard work.
So I've been watching a couple of your videos and I've been getting a flavor for what you talk about and what you're known for. And I think it seems like the main thing that you are known for is insulin, and that you're really trying to break down the barrier in how we think about insulin, and that you're an insulin guru. I want to know, first of all, how did you become an insulin guru? Like, how did you get here?
Yeah. Well, whatever I am, it happened through me being curious. So when I was nearing the end of my undergraduate degree, which was exercise physiology, I'd been studying, I'd been focusing more and more, including the first half of my master's degree in exercise physiology. I was curious about the muscle. I wanted to know what it was about the muscle, what happened in the cells within the muscle to help the muscle adapt to a stimulus, like exercise, for example. Over time, though, near the end of that master's degree, I stumbled across this work that had been published just a couple years before, detailing how fat cells were endocrine organs. So that was the very first time I'd ever imagined that there would be an organ or a tissue that was acting like an endocrine organ that was not the prototypical endocrine glands. Like when you think of endocrine tissues, you think of the thyroid gland or the adrenal glands or maybe the gonads. But the fact that fat tissue itself was releasing hormones was mind-blowing to me. And the fact that they were releasing some of these, if we can call them hormones, which are just proteins that flow through the body, some of these were inflammatory. So they were activating inflammation throughout the body. And that was thought at the time to be part of the mechanism whereby fat tissue caused insulin resistance. So when I read that, it was this immediate curiosity to want to know more about how fat tissue connects to type 2 diabetes. And that was the whole scope at the time that was in my mind. I just imagined insulin resistance was only relevant to type 2 diabetes. Insulin's not working very well anymore and the glucose levels climb and then you got diabetes. But so that was the beginning of me stepping away from the muscle cell, which is something I've not done completely. We still do publish papers from time to time in muscle, including one last year looking at how ketones influence muscle cells. But more now, it has been a shift to fat tissue. I once was curious how the muscles respond to exercise. Now I'm curious how the fat tissue responds to environment, to diet, and how that ends up driving insulin resistance in a large way.
You talk about this, and I remember the first time I heard the term insulin resistance from a doctor to me. It was when I was trying to get pregnant, I think, and they said, you're insulin resistant, you have polycystic ovarian syndrome. Yep. And they said, we're going to, let me help you. We're going to put you on glucophage. And I still look back as I continue to learn more and more. And I really feel frustrated with myself because I'm a very curious person, and you heard this not even in regards to yourself, and you looked into it and you got educated, and I don't know why when I was at the doctor 15 years ago and I heard you have insulin resistance, I didn't understand what the heck that meant. I do to an extent now, but only after 2 years of Dr. Jason Fung and people like you and, you know, all these people I've talked to. But I feel like the general public, when it refers to them and they hear insulin resistance, they don't actually know what it means. They just know to take a medication. So I'm going to ask you two things. Could you, for me, very simply just explain what the heck insulin resistance is? And why do you think we just solve it with a medication and don't try to figure out the root cause of it? I know that's a giant question, but I'd love to hear your opinion.
Yeah. Well, I'm a professor, so I like questions. So what is insulin resistance? I usually define it in two ways. One is that the cells of the body are not responding the same. Certain cells of the body are not responding to insulin the way they used to. So there's an alteration in how the cell is responding when insulin comes knocking at the insulin door, the insulin receptor. And then two, and this is important, it means insulin resistance is a state of hyperinsulinemia. Now that is distinct, but what that means is insulin is elevated in the blood, in the body, and insulin is not working the right way in all the different parts of the body. Now, some parts of the body continue to respond to insulin just like they always did, which becomes a problem because now they're responding to the excess of insulin. And then in other instances, the cell insulin isn't able to turn off a process or to turn on a process. That's the true insulin resistance at the level of the cell. So again, two things. It's insulin isn't working the same way that it used to, and there's too much of it in the blood. And that is important to understand. And then why use a medication? I believe that it really is a consequence of medical school education, where the average physician, I'm sure, would confirm this. Their experience with nutrition at medical school could be zero. And even on the generous end, it is maybe a handful of hours. But even if they've had that exposure to nutrition and disease, I suspect it would be in the context of the dogmatic thinking that it's all about calories in, calories out, and saturated fat's the devil, and you need to eat more whole grains, that same old nonsense that got us to where we are. So I'm almost glad when I can talk to a group of medical practitioners when they haven't had a nutrition class, because I have to do less unteaching before I don't have to empty the vessel before I can fill it.
That makes sense. Yeah, I mean, honestly, the first understanding I ever had of it was Dr. Jason Fung's book, The Obesity Code. And it was suggested to me by a friend who was a doctor because I'd started eating low carb. I'd started eating keto.
Good for your doctor. That's great.
Well, she actually is just a friend. She's not even my doctor. To be clear. She's not even my doctor. She's a friend who is a doctor. And most doctors I've been to suggested bariatric surgery and fitness people and diets, and those were all the things I did. But I really was amazed when I read Dr. Fung's book, and I'm amazed when I hear you talk, and I can't get over the feeling of like I should have asked sooner. So now I get it.
Yeah.
And now I'm more understanding. And the thing for me is that, can you talk a little bit about how insulin resistance relates to hunger? Because for me, I was always hungry until I did things that lessened my issues with insulin resistance.
Yeah. So insulin is a satiety hormone. As much as we always focus on leptin as the satiety signal, that doesn't paint the full picture. Insulin and leptin, and actually other signals as well, play into satiety as a sort of cocktail. But to focus it exclusively on insulin is a satiety signal. When insulin goes up, it normally will tell the brain, energy has come in, we've reached a threshold, we're good. However, that distinct part of the brain, I believe it's a section in the hypothalamus, I think, becomes insulin resistant. We have detected insulin resistance in that distinct section, not my lab, others have. And once it's insulin resistant, it stands to reason that satiety signal that once came from insulin is no longer coming. So insulin is trying to tell the brain, hey, we're full, stop. But it doesn't work.
That's for sure.
Yeah.
For sure. For like 20 years, I felt hungry all the time. And I don't think I understood that if I changed the way I ate or how often I ate and made it less frequent, that I could feel less hungry. And that seems weird.
That's a bit of a paradox, isn't it?
Yeah. But no one ever said that to me. No
Yeah.
doctor, no person ever said that to me. And I just want to repeat that for people who feel lost and desperate and ashamed right now. So can you talk anymore? You've talked a lot about insulin. Any other major misconceptions that people have about insulin, how our body creates it and processes it?
Oh, yeah.
That you find? Like, what would be the major misconceptions that people have?
Yeah, one of the most common misconceptions that I hear is when people try to invoke a fear of fat and saturated fat in particular, and they say the saturated fat will come in and clog up your insulin. I don't know what they say. It's something always wrong and silly. Your insulin channels, and then the body becomes insulin resistant. And that's not true. So this is commonly used by people who promote a vegan or a vegetarian diet. You got to avoid these saturated fats, and they directly are causing insulin resistance as they clog the cell. That's typically what they'll say, something like that. And the reality is not so simple. First of all, people on a low carb, high fat, even high saturated fat, eating 4 or 5 times more saturated fat, actually have less saturated fat flowing through the blood. So the actual amount of saturated fat moving in the bloodstream is less on a high fat, low carb diet, even when they're eating several times more saturated fat. So that kind of blows that idea out of the water. And we can unpack that a bit more if you'd like. And then second, it's not the saturated fat that's the problem. It's what the saturated fat can become. And within a cell, if there is the signal, that's typically caused by an inflammatory event or activating what we would call inflammatory pathways within a cell, it can take an innocent, benign saturated fat and turn it into a type of fat called ceramides. And ceramides now directly antagonize what insulin's trying to do. So insulin comes to the receptor on the cell, knocks on the door, and initiates a series of biochemical events. Ceramides block that from happening. So ceramides are a type of fat, one of the hundreds of thousands of types of fat, frankly, within every cell. So it's a massively complicated area of biochemistry studying lipids. But ceramides directly antagonize the fat. They are derived from saturated fat, palmitate in particular, which is the most common saturated fat we eat in the diet. But that phenomenon does not mean eating saturated fat causes that event. It does not. If everyone has saturated fat in the blood, the liver makes plenty of saturated fat, which could be why the person on a low-fat diet has more saturated fat in their blood, because the liver is making so much palmitate. And the strongest signal telling the liver to make new fat is insulin.
So I never felt full until I started eating more fat. That makes sense, right?
Well, I would say it does, because as you started shifting your diet to eating less frequently and focusing on the 1 or 2 macronutrients that have the least effect on insulin, namely fat and protein, you allowed insulin to finally come down. And with that lowering of insulin, you not only became more sensitive to it, but you also shifted your fuel use. You became metabolically flexible. By that, I mean, in the insulin-resistant person, which is the vast majority of adults in the US now, they are stuck in sugar burning mode all the time. That is metabolic inflexibility. So normally we're only in sugar burning mode when we're very physically active and intensity starts to climb. As intensity goes up, sugar burning goes up and fat burning goes down. In contrast, as intensity subsides and we become increasingly sedentary, like 2 of us right now, we're just talking, we're predominantly fat burning. And that's healthy. We should be able to shift between these 2 fuels. That's metabolic flexibility. And again, inflexibility is when we're stuck in sugar burning mode. And the problem with sugar burning is that we have a very finite capacity to store glucose in the body. And when that store starts to get low, when we start to run out of liver glycogen, and that's only about 2,000 calories, then the body will sense this and will have to eat more and top that glucose reserve, that sugar reserve back up. So we're constantly tapping the fuel tank that's not only really small, but it runs out very quickly. And as someone lowers their insulin They become more fat adapted. Now they're tapping into the energy reserve that's like this massive tank of fuel that can essentially never run out. And thus the body doesn't sense any fuel absence, or doesn't feel like the tank is getting on empty. I often use the analogy of a big fuel tank, like a semi-truck hauling a fuel tank rumbling down the road. And if you look at that big truck, you'll notice the one fuel tank underneath the cabin and the huge fuel tank on the back. That engine is only pulling fuel from that one little tank. So every several hours, that truck has to pull over and fill that tank back up. But imagine if that truck could sort of shift the fuel lines so that the engine was being fueled by the massive tank on the back. It's got to haul it around anyway, all that fuel. Now it doesn't need to stop and fill up as frequently. That's like the human body learning to burn its own fat for fuel. We're hauling all this fuel around on our bodies. It's like we have countless little energy bars that are just waiting to be opened up and used, but we can't use them until insulin is down. And to make this point just so obvious, here in Utah, beautiful mountains all over. People love to go hiking, rightly so. And they'll take their energy bars and they'll take their Gatorade. And all I want is water because I have my own energy bars. They're on my body. I got a little fat here that I'm just waiting to use. And why not just tap into that? And so you saying you didn't feel as hungry, I would contend that it's largely, or at least partly, a consequence of your body learning how to use fat for fuel more readily. You became metabolically flexible. And so if your body is deprived of some glucose for a little while, it doesn't panic. It doesn't sense an energy deficiency because it just says, oh, no problem. I'm a hybrid engine. I'm just going to shift to this other fuel because I got a lot of it just waiting to be used.
Yeah. You know, the other thing I noticed too is like most of the time I eat low carb and high healthy fats, and I do intermittent fasting. But when I go off track, let's say I go on vacation or I go to a party and I celebrate, and maybe I celebrate for 2 more days after, maybe with my family or whatever. Let's say I do 2 or 3 days of celebration and I do have some sugar, and not a lot of sugar, but more carbs, right? Like that I don't usually eat bread or pizza or whatever. I noticed that I used to gain maybe 7 or 8 pounds. And this is when I was weighing more. And now I'll only gain 2 pounds. Is that anything to do with that insulin flexibility you're talking about?
Yeah. Well, it would perhaps partly be that, but that acute shift in weight would almost certainly be due to insulin's ability to tell the body to retain water, which it does exquisitely well. So when someone's noticing that fluctuation, especially over just a couple days of debauchery, dietary debauchery, it's going to be not a change in fat mass, it's going to be water. Insulin tells the kidneys to retain sodium and water, which is why the weight goes up and which is why blood pressure goes up. That's also why
blood goes up so much less than it used to.
Yeah, well, it probably is because your insulin is just so much better in control. What used to be a spike and it was climbed up into the, dozens, 40, 50, 60 microunits. Now for you, it just gets up to 20 or 30 perhaps and just comes down much more quickly.
That's interesting.
In fact, I'm certain that's the case in your case. As you become more insulin sensitive, you could eat what once would have been an amount of carbs to keep your insulin elevated for 4 to 5 hours, and now it's up and down in 2.5.
Because I'm getting better. Because I'm
well, you're just more insulin sensitive. So the body takes that glucose load and it says, all right, I only need this much glucose. I only need this much insulin to clear that glucose out. So I'll just spike up my insulin. It'll work. The job is done. In the insulin resistant person, they take that equal load of glucose, and now the pancreas has to work and work and work, and insulin goes much higher and stays higher for longer just to get that same effect of clearing the glucose out.
Dude, when you're obese and you're eating a little bit more and it's so much less than the family member next to you, and then you pack on the weight, it just makes you feel so crappy about yourself.
Oh, I can only imagine how discouraging that would be. Really,
a loser. Like, and we're dealing with all the same hormones and chemicals, and it's so frustrating. Anyway, let's talk about something weird. You ready? In a recent video, you were talking about the taste of urine as one means early physicians use as they try to understand more about diabetes. Number one, thank you, doctors, for sacrificing that. Number two, why the hell were they tasting urine, and what did they learn from drinking pee? Yeah,
that's an excellent point. Excellent question. So what did they learn? So they didn't taste it until they noticed the flies coming to it, at least according to the history of all this. So Indian physicians noticed that the urine from these people that were losing weight so quickly, they were wasting away. And the idea was almost that the urine, that the body was melting, like because they would just waste away and all their fat was going away, their muscle, their bone. They just became, terribly scrawny. And the idea was that the body was leaking this out into the urine. And that's where the term diabetes comes from. It just is reflective of the polyuria, or the excessive urine production. So these early physician scientists noted that the urine from these people that were wasting away, it attracted a lot of flies, and dogs would come and lick it up. And so then one physician, more recent than that, would tasted it and then noticed a subtle flavor. Now, interestingly, glucose itself is not overly sweet. Of course, it's fructose that's sweet. Yeah, glucose alone is not particularly sweet, but nevertheless, there would have been enough there to give it a decided taste difference.
Okay.
Now, the reason that's important, I believe, to modern medicine is that observation put all of diabetes, type 1 and type 2, into one family of glucose. These became glucose diseases. They were diseases of excess glucose, type 1 and type 2. Now, unfortunately, over time, that perspective, I believe, has become less and less forgivable, and it's time to change, because those diseases are in fact opposites. Type 1 diabetes is a disease of deficient insulin, and then type 2 diabetes is a disease of too much insulin. It's just not working well, so insulin resistance. The fact that they both have elevated glucose levels in common, I would say, is a secondary is of secondary importance. The reason I emphasize this is that if we can look at type 2 diabetes as an insulin disease rather than a glucose disease, two things that are very important happen. One, we stop looking at glucose as the key marker of the disease. And when we do that, we can detect the type 2 diabetes much earlier. In fact, there are studies known that if you're tracking the patient, looking at their glucose and their insulin, insulin starts to climb decades before the glucose does. And so by waiting until the glucose climbs, then we detect it far later than we needed to. If we were looking at the insulin, we would have detected it much, much earlier. So that's one important point if we shift the paradigm and look at insulin. Second, I would argue we treat it significantly better. If we acknowledge that in insulin resistance, insulin is elevated and then glucose is normal, and then even in type 2 diabetes, when insulin is still elevated and glucose is now elevated, if we try to just look at it, if we look at it only as a glucose disease, we just say, whatever we got to do to push the glucose down, we're going to do it. Even if that means bumping the insulin up even higher than it was before. And that drives
more insulin resistant, right?
Well, that's right. It makes you more insulin resistant, makes them gain weight. It makes them die more from cancer, die more from heart disease. All of this is published data. So their risk of cancer and heart disease mortality is 2 to 3 times more than it would otherwise be. So if we just look at it as trying to push the glucose down, regardless of what we do to insulin, that's a wrong way of looking at it. In contrast, if we say this is a disease of too much insulin, what can we do to lower the insulin? Then I would argue that logically leads to a lifestyle change of just, let's cut the carbs. If rather than give you drugs that push the glucose out into the urine, rather than give the person drugs that blocks glucose digestion or starch digestion in the intestines, let's just put less glucose into the body. That will help the glucose come down. It'll help the insulin come down. And now we're really addressing the problem. So if we look at it as an insulin disease, we detect it sooner. We can lower the insulin, which starts to resolve not only the diabetes, but then the countless other pathologies that come from insulin resistance, like PCOS, one you mentioned earlier, and many, many others.
Yeah, absolutely. Thank you for explaining it like that. I hadn't heard it talked about that way, and I loved it. Okay, so when did you transition from thinking of ketones as metabolic garbage, and what do our listeners need to understand about this new viewpoint you have about ketones?
Yeah. So I did have to grow through that, just like most, I would believe. I was taught in my nutritional biochemistry class that ketone was quote unquote metabolic garbage, that it was nothing. And that it was only something to be viewed as in a pathological setting. In other words, if you detect ketones, it's dangerous. And that becomes relevant in the context of an untreated type 1 diabetic. If the type 1 diabetic is deliberately, say, underdosing their insulin in order to stay thin, which works extremely well, that's a disorder called diabulimia. The person will deliberately skip their insulin injections to stay skinny, and they do, but they have massive hyperglycemia and massive ketoacidosis that kills them, but they look great in their coffin. They just the body size they want to be, but they die young. Nevertheless, in that case, ketones are decidedly a warning sign. In the rest of us that are not type 1 diabetics, or even in the type 1 diabetic who is just giving insulin based on what the glucose demands are, what the glucose demands in the blood, in that case, a person can be in a mildly elevated state of having ketones, which we call ketosis, not ketoacidosis. And the difference is ketones are elevated, but not to the point that it affects pH in the blood. So the acid-base balance stays perfectly normal. But I've shifted the topic a little. So metabolic garbage, when I started, that's what it was once considered. When I started to try to find the best studies published to most effectively lower insulin, I had to start using search terms like ketogenic diet to find some of the relevant research. So I came to the ketone because of my appreciation for insulin. And you aren't making ketones unless insulin is elevated. Or in other words, if insulin is down sufficiently for a long period of time, the body becomes ketogenic. It starts making ketones from all the fat that it's burning. Just like I talked about earlier, the body's so able to burn fat that it burns enough, in fact, more than it needs, arguably, and starts turning some of the fat into ketones. So again, I had to start using those terms because it allowed me to find more human research. So I would go to online databases like PubMed or Google Scholar, and I would have to put in quotes, ketogenic diet, and then whatever the health outcome I was looking for, ketogenic diet hypertension, ketogenic diet polycystic ovarian syndrome, or whatever the situation was. And then that enabled me to find better studies, more relevant for what I wanted in the teaching material that I was preparing at, in whatever topic I was working on. Now, importantly, as if some listeners start doing that, my only note of caution is be careful in the animal studies that we use and rely on. Many animal studies that put the animals onto a ketogenic diet have almost all of the fat coming from corn oil or soybean oil, and that is not a good way to do it. Earlier you'd said low-carb healthy fat. I agree. By healthy, I define healthy as natural fat, which is a fat that comes from an animal or the flesh of a fruit. These are fats that we would have been eating since time immemorial as a species, and those fruits would be coconut, avocado, olive, and then again any animal fat. So studies that are putting an animal into a ketogenic diet make sure that it is a well-formulated version of it. So in other words, the fat is not coming from one of those industrial seed oils.
Dr. Bikman, thank you so much. 2 last questions.
Yep.
If a person feels, let's say they're starting off in this world and they're insulin resistant, they're type 2 diabetic, they're struggling with health, and they want to improve their health, they want to feel better, what is one first step you might suggest? Yeah,
I would say change breakfast and start tomorrow. It is, I think, particularly tragic in our diet in most of the world at this point, as I've traveled the world and giving talks about insulin resistance. Everywhere that eats breakfast, everywhere, they start breakfast almost without exception with high sugar, high starch foods. I think that is terrible. Insulin has finally come down overnight. We eat dinner, even if it's a crappy dinner, high sugar, high fat, high starch, low protein, as so many processed foods are these days. Even still, in that terrible dinner, insulin has finally come down throughout the night as we've been sleeping. And so the person wakes up and insulin is a little low. In the healthy person who's metabolically flexible, they might even be in a hint of ketosis at that point. But even if they aren't, insulin has worked hard all night to clear the glucose and to come down. And how terrible that we just shoot it through the roof for breakfast, and we do it again 2 hours later. We do it again 2 hours later because they're always trying to fill up that little sugar-burning tank for the rest of the day because that's what they're burning. The body is in a bit of a fat-burning stage when they wake up. Let it keep going. Change breakfast tomorrow. you don't have to, I'm not saying skip it if the person feels like they need to, although that is a very viable option. Just drink a cup of tea or something similar. But if they're going to eat breakfast because they need something in their stomach, although they don't, but if they felt like they needed it, focus on protein and fat. Those are the two essential macronutrients for humans anyway, and they're the ones with the least or mild effect on insulin. And so you can keep the body in that fat-burning stage that it's worked so hard to get to overnight. So change breakfast, start tomorrow.
I love that. Thank you so much for everything you shared. Where can people find out more about you? Also, you mentioned like a study that's coming out or around keto, I believe. Where can they hear you speak? Where can they find out everything about you?
Yeah, thank you. We do have papers being published all the time. We're just about to submit for review a paper that we have data from individual fat cells, data from mice and humans, that if the fat cells are exposed to ketones, the metabolic rate in the fat cell goes up about 2 or 3 times. So the actual metabolism within the fat cell itself, the metabolic rate is significantly higher. And this could explain part of what we see from the whole body level, that when people are in ketosis, their metabolic rate is about 100 to 300 calories higher than when they're not in ketosis. So that's a very real metabolic advantage to being in ketosis.
I like being able to eat more. I'm all about that.
Yes, exactly.
Right?
And then where can they find me? I'm pretty active on social media. It's only ever science. It's never me or about me. I have too many. I'm one of 13 kids. The idea of having that much attention is unsettling for me. So
I'm an only child. I'm the opposite. I got you. I need all the validation, and you need a smart person. This is perfect.
Yeah, you and I would get along great. Yeah. Because I don't want the attention. You can have all of it. So I on Instagram and Twitter, I just share studies from time to time, a couple times a week, and that's Ben Bikman, PhD. And then I have a public profile page on Facebook, and someone can find me there, just Benjamin Bikman.
And that's Bikman.
No C, just B-I-K.
No C? Did I spell
No
it
C.
wrong? Yeah, we're going to edit that out.
You're going to edit that.
Byron, edit that out. Bikman. Oh, sorry.
Yeah. So that's B-E-N, and then Bikman is B-I-K-M-A-N. No C. Don't insult my Jewish ancestors by slipping a C in there.
Sorry about that.
B-I-K. Yeah, no problem. And then I have a book coming out in July, and anyone who is curious about what we talked about, I go into it in a great amount of detail, and that is called Why We Get Sick. And the general premise of the book, Why We Get Sick, is that insulin resistance is relevant to every chronic disease, non-infectious chronic disease, and we just scratched the surface now. And what is insulin resistance? So why does it matter? What is it? And then what to do about it? That's the kind of 3 pillars of the book. Again, it comes out in July. It's available for pre-order anywhere books are sold.
Is it available for pre-order now?
It sure is.
Okay, great. We're going to put a link for that for sure. So tell us the name of the book one more time. Why We Get Sick?
Why We Get Sick.
That sounds fascinating. I can't wait to read it. Okay, so since you said that, I'm going to talk about my book, which is Life in the Fasting Lane, that I co-authored with Dr. Jason Fung and Megan Ramos. And the reason I'm saying it is Dr. Bikman is one of the 5 people we sent the early book to and exposed ourselves and hoped they would say nice things, and he was pleased to us. So we really appreciate that so much. Like I'm so grateful for that. Thank you for reading it. Thank you for sending us a quote.
It was a great book. It really was. I meant what I said. It is a fun mix of science and not anecdote, but just experience. That combination of the experience of people doing this with the scientific perspective, putting it in context, it does make for a pretty fun read.
Thank you so much. You know, when I started reading books, like I have to just be honest with you, I am not as smart as some people. I'm not as smart as Dr. Jason Fung. I'm not as smart as Megan Ramos. And I've learned 30 minutes now. And I am not as smart as you. I kept up with about 80% of what you said, but I got to go back and listen to it again. So I actually understand all of it. So the purpose of Life in the Fasting Lane, the book, was to say, here are these 2 incredibly smart people. And here is this regular girl who has failed in every way, is just going to tell you, like, net it out like she's your best friend. How to
stop failing metabolically. That's it.
That's it. Thank you so much for being on our podcast, Dr. Bikman. We so appreciate it.
Oh, my pleasure. It was absolute pleasure. Really, Eve, thanks for reaching out. Thanks for the invitation.
Thank you. Guys, thank you so much for tuning into the Life in the Fasting Lane podcast. Till next time, to your health and hotness.